So we've done inverse functions before. So we would have equations like y equals 2x plus 3. And to find the inverse, you would swap the x and the y, and then you would solve for y. You would get y alone again. So like here you would subtract the 3, x minus 3 equals 2y. And then you would divide by 2. So you get y equals x minus 3 over 2. So that's what we did back in the day. And this is very similar. Now, you might remember from Algebra 1 days that there was a vertical line test to determine if an equation was a function. And the vertical line test said if you could draw any straight up and down line and it touches the graph in more than one place, not a function. So when we're doing inverses, we're going to go with a horizontal line test instead of a vertical line test. So if you look at example A here, if you draw a horizontal line anywhere through that, it's not going to hit the graph more than twice. Whereas on B, if you draw this horizontal line here, it goes it hits it 3 times. So it's not an inverse function. The inverse is not a function. So if you look at the one example we have to do here, can you draw a horizontal line and hit this curve in more than one place? And no, you can't. So this is fine. So we would say the inverse is a function. The inverse is a function. Because you can't draw a horizontal line through both parts. So let's kind of get this one started. We might have a chance to do this here. To write the rule for an inverse function, you exchange the x and y and solve the equation for y. Because the values of x and y are switched, the domain of the function will be the range of its inverse and vice versa. So if you look here, let's think of the domain and range as it is. Domain, are there any limitations on what you can put in for x? When you're doing cube roots, it's fine to have negative numbers. So there's no limitations on the domain. So we would say all real numbers. The range is all real numbers as well. So when we do the inverse function of that, those would flip-flop, which would give you the same answer, but the range would become the domain of the inverse. The domain would become the range of the inverse. So here's what we're going to do. Remember, f of x is essentially y. So we're going to flip-flop the y and the x. So this would become regular x. Over here, we'd have the cube root of y plus 1. Now we're trying to solve for y. So we need to get rid of the cube root. The opposite of cube root is cubing something. So we have x to the third equals y plus 1. Now we just have to get rid of plus 1 by subtracting 1. So we'd have x cubed minus 1 equals y, or in our case, f of x. So this would be the inverse function, which if you want to write y equals, then that would be fine. Remember, the domain and range flip-flopped, but they were the same thing anyway, so that really didn't make a difference. So let's try that on this. We might not have enough time, but I'll try. So we're going to flip the x and y. By the way, in the original function, domain is anything. You can cube anything. Same thing with the range. It could come out to anything. So the inverse and the regular function are both all real numbers for domain and range. Okay, we're going to get rid of minus 2 by adding 2. So we'll have x plus 2 equals y to the third power. We don't want y to the third, so we cube root both sides. And that'll be our final answer then. Cube root of x plus 2 equals y, or f of x if you want to say it, or f inverse of x.